Okay, chemistry. So we're going to go into stoichiometry, which really is a core part of chemistry. So it's basically figuring out how much of one thing in a reaction will be made if you only know so much at the beginning. So let me go through an example of this. And what I'm going to do, I'm going to give you a strategy. And this strategy is a pre-calculation method. So your book and other resources have a different method that involves, I guess, more steps. And that's fine. If you like that method, great, use that one. This is a method that I like because you pre-calculate everything, and then getting and answering a question then is always in one step. So let me describe what this looks like. So again, stoichiometry. So I'll look at this reaction. This reaction, I'm taking carbon in a solid form, maybe a graphite or maybe diamond, who knows, and combining that with sulfur dioxide, which is a gas, and this is going to produce carbon disulfide as a liquid and some carbon monoxide gas. And the problem is that I say I know I have 12 grams of carbon that I'm starting with, and I don't know, well, how much carbon disulfide is that going to produce? Yeah, I don't know. So what this is what we're going to do, we'll figure it out. Or suppose I have 20 liters of SO2 gas and more than enough of everything else. How much carbon monoxide gas am I going to produce? Well, I can figure this out. So the strategy again is that we do a lot of pre-calculations, and then answering the questions is always done in one step. Okay, so here are the things we're going to go through. So first thing I'm going to do whenever I see a chemical equation, I want to make sure it's balanced. Yeah, this one's not balanced. So I'm going to start someplace. I don't know, I'll start with this one. And I'm going to balance this. Let me see. So I've got a sulfur here and two sulfurs here, so I'm going to need at least two of these. I've got an oxygen here, so I'm going to need two of these. Yeah, so I'm going to need two of these at least. See, I've got now 4 oxygens, and the only place oxygens show up is here. So I'm going to need 4 of these. Grief. And then I've got to make this work out. So now I have 4 carbon plus 1, so it's 5 carbon. So I must have 5 carbons here. Let me check to make sure this works out. So I've got 5 carbons on this side and 1 or 5 carbons on this side. I've got 2 sulfur on this side, 2 sulfur on this side. And I've got 4 oxygen on this side and 4 oxygen on this side. I'm good to go. Okay, now remember what this balancing does. So this balancing tells me that if I take 5 carbon and combine it with 2 sulfur dioxide, I'll produce 1 carbon disulfide and 4 carbon monoxide. Or if I take 5 dozen carbon, I need 2 dozen SO2 and 1 dozen CS2 would be produced. Or as we like to do in chemistry, if I had 5 moles of carbon, I would need 2 moles of sulfur dioxide, and we're going to use the mole. So the table is going to have 4 rows that we're going to use. So in that first row of the table, this is just going to be the number of moles of each of these. Right? So for carbon, right, from the chemical equation, all I'm doing is I'm taking the number from the balanced chemical equation that if I know if I have 5 moles of carbon, my chemical equation tells me that when I start with 5 moles of carbon, I'll need 2 moles of sulfur dioxide. I'll produce 1 mole of CS2, and I'll produce 4 moles of carbon monoxide. So I'm going to keep track of this. So it's really important that I put the units in here and of what. So this helps me later when I do my actual calculation I'm interested in. Right now I'm just pre-calculating stuff. Second thing that I want to do is, well, I want to figure out the total mass. So how much does 5 moles of carbon weigh? Well, let me look that up, right? So I'm going to go to the periodic table. I'm going to look at 5 moles of carbon, and I'll look on periodic table and discover carbon has a mass of 12.01, so I'll end up with 60.05. So that's going to be 60.05 grams of carbon, right? And all I'm doing is I'm just working. Oops, there it is. I'm just working my way down this column, right? So 60.05 grams of carbon is equivalent to 5 moles of carbon, and that's the equivalent of what I have there on the first line. Second one is SO2. So I'm going to do the same thing. So I'm going to have 2 moles of all of this stuff, right? So I'm going to have sulfur, which is what is it, 32.06. plus oxygen, and I have 2 oxygens, so 2 times 16.00. I want to be careful. So each SO2 is going to be something like 64, but together that's going to be 128. So I need 2 of those SO2 molecules. So I'm going to add this up to have 128.02 grams of SO2. Again, I'm going to be careful. So the molar mass of SO2 is 64, and the molar mass of 2 of those is going to be twice that. 2 more to do, so I have carbon disulfide, and I'll do the same math on that and discover that 76.05 grams of CS2. And carbon monoxide, I'll do that math and I'll discover that's 112.04 grams of carbon monoxide. Again, each carbon monoxide is only going to be 28. But I've got 4 of those, so I'm going to end up with a larger total mass. Okay, next thing I'm going to do is I'm going to do a check. Right? So I can't make or destroy matter in my chemical reactions. So, whoops, this is going to be 4. So I can't make or destroy matter in my chemical reactions. So the amount of mass that I start with should equal the amount of mass that I end with. And it's really easy to make a mistake in here someplace. So this is a good place to check to make sure you haven't made a mistake. So I'm going to add these 2 together and see how much mass did I start with. So I'm going to start with 160, so I'm going to 188.09 grams. And let me add these together and see how much mass I ended with. And I ended with 188.09. Okay, good. 99 grams. Right. And this is just a check. Right? I'm not going to use this in any calculations, but this is a way that you catch mistakes. It's really easy to make a simple math mistake someplace in here, and you can go back and check it. The last thing I'm going to do is I'm going to figure out, for those things that are gases, I'm going to figure out the volume of a gas. And for this, I'm going to go back to recall that if I have 22.4 liters of any of a gas at standard temperature and pressure, which is 0 degrees Celsius and 1 atm, that's going to equal 1 mole of that gas. So for those things that are not gases, right, this is solid, so yeah, this doesn't apply, so it's not applicable. For those things that are gases, though, I'm going to multiply the number of moles by this number. Right? So I'm going to have 44.8 liters of SO2. This is a liquid, right? So not a gas, doesn't apply. This is a gas, so I'm going to have 4 times that, so it's going to be, what's that, 89.6 liters of carbon monoxide. Okay, so now I've done the hard math, right? So I've figured out the number of moles, or the mole ratio in my equation. I've figured out the mass ratios, right? So this is telling me for every 60.5 grams of carbon, I'll consume 128.4 grams of SO2, and I'll produce 76.5 grams of CS2. And I'll produce 112 grams. And also I've put in there the volume of a gas. So if I started with 44.8 liters of SO2 and I used all of that, I would produce 89.6 liters of carbon monoxide. And now we can answer questions, right? So first question, let's see. So suppose I want to figure out, say I want to figure out how many grams of CS2 will be produced when I start with, I don't know, 36 grams of carbon. Right? So now I'm going to do this in one step. So this table, I can go from one thing in the table to anything else. So here's the strategy. So I'm starting with 36. So I'm going to start with my 36 grams of carbon. I'm going to put that over 1. I'm going to multiply it by some fraction, and I'm going to follow my units. So I'm going to find on my table, I'm going to find my grams of carbon, and I'm going to put that down here. right? That's what I'm starting with. So I'm going to find my grams of carbon. Here it is, 60.05 grams of carbon. 60.05 grams of carbon. Now on the top, I want to get to grams of CS2, right? So here I go. I'm going to find grams of CS2, and I'm just going to go find that on my table. I'm going to find grams of CS2, and that's here. So 76.05. 76.05. And now I get my calculator out and I can do my answer. So notice what I've done here. My units are going to cancel, so it's going to work out. And when I get my calculator out, so I should have figured this one out before, I'm going to multiply 36 times 76.05. I'm going to divide that by 60.05. Whoops. 60.05 and end up with 45.6 grams of CS2. Right? And this is the idea and the strategy behind this. So you're doing more work up front. Right? So we have to balance the equation. We have to copy down the number of moles. We have to calculate the mass of that number of moles of that stuff. We'll do a check to make sure nothing went wrong with the mass. We can add up the gases, the effect of the gases, by multiplying the number of moles by 22.4. And then I have a table that has a lot of information, and I can get from anything in the table to anything else. Right? So if I'm given grams of SO2, I could figure out how many grams of carbon there were. If I was given moles of CS2, I could figure out how many liters of SO2 there were. So I go from one place in the table to any place else that I want to, and I can get to any of those calculations in one step. Anyway, this is called TableStoich, and we'll get some more practice with it. Hope that helps. Talk to you soon. Bye.